We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the application of Rouche's theorem from the section complex analysis. This problem is from the part B. It is a multiple choice question carrying 3 marks, and this bears the question ID 704036. The given question is, how many roots does the polynomial z to the power of 100 minus 50 z to the power of 30 plus 40 z to the power of 10 plus 6z plus 1 have in the open disk, that is the set consisting of all those z belongs to C, such that mod z less than 1. It is a circular neighborhood of 0 with radius 1, that is same as the open disk. And you are given a polynomial. This is the polynomial of degree 100, and we want to find how many roots does this polynomial have in this open disk, and we are given 4 options. Right. Let's now discuss the solution of the problem in detail. And by looking at this problem, and it is a very familiar problem. Problems of this type we might have done it in our classroom, and problems of this type are worked out or solved using the famous Rouche's theorem. And it states that suppose f of z and g of z are analytic inside and on a simple closed contour C with modulus of g of z is strictly less than modulus of f of z on the closed contour C, then the conclusion is f of z plus g of z has the same number of zeros as f of z inside C. It talks about only the number, but not the zeros of that one. So the number of zeros of f of z plus g of z is same as the number of zeros of fz inside C. Zeros means roots of. So zeros of f of z plus g of z must have the same number of zeros as f of z inside C. Right. And to apply Rouche's theorem, we need a simple closed contour. So we go to the unit disk, the open unit disk there. So we take the contour C to be mod z is equal to 1. Right. Let C be the unit circle, that is mod z is equal to 1. It is a very simple closed contour, and the meaning of simple closed and the meaning of contour we are very familiar. Right. Now we look at the polynomial. We have to choose f of z, g of z appropriately in such a manner the conditions of Rouche's theorem are valid. And we have taken here f of z is equal to minus 50 into z to the power of 30, and the g of z is the remaining part of the polynomial, that is z to the power of 100 plus 40 z to the power of 10 plus 6z plus 1. Yeah, these are analytic everywhere. So they are analytic inside and on this simple closed contour C, which is the unit circle. Why they are analytic? Because they are polynomials. Because they are all polynomials are analytic everywhere. So, because they are polynomials, f of z and g of z are analytic inside and on this closed contour C, which is the unit circle. Right. We have to verify this condition, mod zz less than mod fz on C. Let's take mod of g of z. That is equal to mod of z to the power of 100 plus 40 z to the power of 10 plus 6 z plus 1. Modulus of the sum is less than or equal to, sum of their moduli is less than or equal to mod z to the power of 100 plus 40 mod z to the power of 10 plus 6 times mod z plus 1. So on C, mod z is equal to 1. So this is 1 plus 40 plus 6 plus 1. That is 46 plus 1, 47 plus 1, 48. So this is equal to 1 plus 40 plus 6 plus 1, that is equal to 48 on C, that is the unit circle. And look at mod fz. Mod fz is equal to mod of minus 50 z to the power of 30. That is 50 into mod z to the power of 30. So on C, mod z is equal to 1. So on C, mod fz will be 50. Right. So we now continue our discussion in the next slide. This is what we have done so far. Right. Mod gz we know, mod fz we know. So on C, that is the unit circle, mod gz is less than or equal to 48, which is strictly less than 50, is equal to mod of fz. Yes, it is mod of fz. So this condition, mod of zz is less than mod of fz on C. That is the unit circle. Right. Thus, the conditions of the Rouche's theorem are verified and they satisfy the conditions of Rouche's theorem. Therefore, by Rouche's theorem, fz plus gz, that is the whole polynomial, that is z to the power of 100 minus 50 z to the power of 30 plus 40 z to the power of 10 plus 6 z plus 1, the whole of the polynomial fz plus gz has the same number of zeros as f of z. F of z is minus 50 z to the power of 30. That is by Rouche's theorem. So, by Rouche's theorem, f of z plus g of z has the same number of zeros as f of z inside C. We are only talking about the number of zeros, but not the exact zeros of these functions. We are not talking about these zeros, but we are talking about the number of zeros. So, what is f of z plus g of z? The whole of the polynomial, that is z to the power of 100 minus 50 z to the power of 30 plus 40 z to the power of 10 plus 6 z plus 1 has the same number of zeros as f of z, that is minus 50 into z to the power of 30 in the open disk, in the open unit disk. Inside C means C is the unit circle. Inside C means inside the open disk, the unit open disk, mod z less than 1. Right. Now, let's go and see how many zeros are there for this f of z. F of z is equal to minus 50 z to the power of 30 has z is equal to 0. Z is equal to 0 is a 0 of f of z in the open disk at the origin. But it has the multiplicity 30. That is, this 0 is repeated 30 times at the origin in this open disk. So, by this Rouche's theorem, this whole polynomial will also have 30 zeros in this open disk. So the answer to this question is 30. We see that z is equal to 0 is a 0 of f of z, that is minus 50 into z to the power of 30. With multiplicity 30, that means z is equal to 0 is repeated 30 times. And whenever there is a multiplicity comes and you have to count them, so many number of zeros. Multiplicity 30 means these are 30 zeros in this open disk. Therefore, this whole polynomial z to the power of 100 minus 50 z to the power of 30 plus 40 z to the power of 10 plus 6 z plus 1 has 30 roots in the open unit disk. So, let's look at our options. Our answer 30 appears against option 3. Therefore, the answer to this question is option 3, that is 30 roots in that open disk. That is the detailed discussion of the solution of a problem, which is an application of Rouche's theorem from the section complex analysis. It is definitely an easy question. Right. I am sure that you have understood the solution of this problem, and I make an appeal to all the viewers watching my videos on mathematics. The appeal is, if you like my presentation, if you like the content of my lectures, please like and share my videos and subscribe my channel. I wish you all the best. Thank you.